Venus here. Gio's here. Ravina, Charlene, Chantal, Erin, Nathan, Lauren, Samuel. Oh, Lauren's coming late. That's right. Amy, Diana, Ben, Chloe, Savannah, Micah, Angela, Kylie, Alden, John, Wadissa, Jacob, Stuart, Manning, Evan, and Yun. Everybody's here. Angela, quizzes. John, quizzes. Jacob, quiz. Oh, whoops. Now I don't know who to belong to Angela. There you go. And okay, we are on page 100. 100. Alrighty, pure substances. In a pure substance, the particles are all the same. So if you look, we have 4 samples of pure substances. In sample number 1, what kind of particles do we have? What kind of particles are those? Those are all atoms, and the atoms are all the same. What kind of particles do we have in our second sample? Tell your partner what kind of particles are in that second sample. What are those? They are molecules, MCs. And the molecules are all the same. Is this substance an element or is it a compound? This is an element. Okay, so we have an element here. Page 100. Are you good now? Okay, cool. I was like, am I on the wrong page? I don't know. Now, what kind of particles are in this one? Molecules. And the molecules are all the same. And that's why each of these samples is a pure substance, because the particles are all the same. Is this, the third one, is it an element or is it a compound? Compound. Because we have two different elements bound together. Is that an ionic compound or is it a covalent compound? Tell your partner. And then if you decide which one it is, tell them why you think it's that choice. So, are they ionic or are they covalent? Evan, I believe you have an answer for us. They're covalent, yes. Why are they covalent? Yeah, molecules are only made of nonmetals. And nonmetals, how do nonmetals bond to one another? So anytime you see a molecule, you know that is a covalent compound. In fact, often we will call covalent compounds molecular compounds. We use those two words interchangeably, okay? Covalent compounds are molecular compounds. Molecular compounds are covalent compounds. They mean the same thing. Okay. So I said that we had 4 samples of pure substances, and so far we've only looked at 3. And we have dealt with elements, or sorry, we've dealt with atoms, we have dealt with molecules, and now we are dealing with formula units. The particle here is a formula unit, and remember, a formula unit is like a molecule, but for a ionic compound. And CMPD stands for compound. But what you'll notice is that every formula unit is identical to every other formula unit. There's a green circle and a black circle. Green circle, black circle. Green circle, black circle. Green circle, black circle. Every formula unit is identical. Can ions exist on their own? No. Can you imagine if I got a bunch of chloride ions, Cl minus, Cl minus, Cl minus, Cl minus? What do negative do to other negatives? They repel. Can you imagine if I put a bunch of negative charged ions together, what would they do? They would just blow apart because they would repel one another. The only way that ions can be in a stable state is to be beside an ion of the opposite charge. Okay, so ions are always part of a compound. I would like you to answer these questions to your partner. Are all molecules compounds? Explain. Are all compounds molecules? Explain. And then we will talk about it together. Let's start with the first one. Are all molecules compounds? No. Why not? You can have molecules that, so you can have molecules that are compounds, but not all of them. Okay, H2O, we got our oxygen with our two little hydrogens. But some molecules are elements. H2O has H's and O's. H2 just has H's. Are all compounds molecules? What do you guys think? Are all compounds molecules? No. Are some compounds molecules? Yes. What kind of compounds are molecules? Covalent compounds. But some compounds exist as, what do they exist as instead? Formula unit or crystal lattice, okay? And I'm gonna choose crystal lattice, and I'll put like in brackets formula unit. And those would be your ionic compounds. And all of this is going to become really important when you start naming and writing formulas for these, because being able to recognize, do I have a molecule? Do I have an ionic compound? It'll also come in handy when we're making solutions, like what happens to the stuff when it dissolves. Ionic compounds split apart into ions. Molecular compounds do not. So pure substances can be either elements or compounds. I think we've said this before, but the element contains only one type of atom. Compounds, on the other, contain two or more elements, and they must be bonded together. Compounds can either be molecules or they can be ionic crystal lattices. What kind of compounds form molecules? Covalent compounds. And here's a tough one. What kind of compounds form ionic crystal lattices? That was meant to be sarcastic. What kind of compounds form ionic crystal lattices? Ionic compounds. Molecular compounds, all non-metal all the time. Okay, all non-metal all the time. And of course, since it's a covalent compound, it is held together by covalent bonds. And what happens with the electrons in covalent bonds? They are shared. Ionic compounds, we don't have atoms, we have alternating cations, which are the metals, and we have the anions, which are the nonmetals. Alternately, the cation or the anion, instead of being like a single metal or a single nonmetal, it could be a polyatomic ion. Okay? What is a polyatomic ion? Describe that to your neighbor. What is a polyatomic ion? What does poly mean? Poly means two or more. It means many. If you are a polyglot, it means you speak many languages. Polyglot. Glot, like the glottis, it's like the tongue. Okay? So if you are a polyglot, you speak many languages. Sadly, I am a monoglot. They do, don't they? Well, monoglot kind of is an insult because I'm a monoglot. I can really only, I mean, I can speak a little bit of Spanish, but it's pretty sad. A Lord of the Rings creature, a monoglot and a polyglot? Yeah, very good, very good, I like it. Anyway, poly means many. If you have a polygon, it has many sides, yes? Atomic obviously refers to atoms. An ion means it has a charge. So a polyatomic ions is many atoms stuck together that have a charge. See if you can tell your partner any examples of polyatomic ions. See if you can remember any from grade 9 or 10. I know, it's been a long time. I don't either. What do we think? Anybody remember any? Ammonium. NH4 plus is ammonium. It really is the only positive polyatomic ion. There is mercury one, but it's kind of its own weird little special self. How about, can we think of any that were negative? Sulfate, yes, 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 sulfate. Sulfate. Bicarbonate, yes. Are these ringing some bells? They're sounding vaguely familiar. Okay, not like you need to know them for right now, but it is good to note that, how many capital letters do you see here? 2. That means how many elements? 2. How many capital letters here? 2. So how many elements? 2. How many capital letters here? 3. So how many elements? 3. All right. So there's many, many different polyatomic ions, and when we come to the naming and formulas section, you will get a chart with them. Okay, so don't worry about having to memorize them. They will be provided for you. Okay. What's that? Which one's an element? Phosphorus is an element. Phosphate or phosphite are your polyatomic ions. Okay. Now, this is just a lovely little chart that kind of like summarizes pure substances for you. Pure substances can be elements or they can be compounds. If they are elements, they can either be atomic or they can be molecular. If you have a compound, it can either be molecular or it can be ionic. Okay? There we go. Oh, and look, we have some questions. Now, I'm not sure, how much of last day's work did you actually get done? Did you get the whole thing done? Did I assign all the, you got them all done? Excellent. So for now, what you're going to do is you're going to work on these questions. And then, but at about quarter after, we are going to take a look at density. Okay? Yeah, math again. I like. Thank you. Right in there's great. Hi. Uh, either way, either one will work. Yeah. Yeah. Okay. Yeah. Well, tomorrow's the 20th, but I believe it's the 27th, isn't it? Yeah. Okay. Yeah, for sure. I was just having a little heart attack. I'm like, I'm not ready. Yes. Homogeneous and heterogeneous. That's two mixtures. So when you have a homogeneous mixture, it will be like the same throughout. So this would be homogeneous because it's randomly and distributed all the different particles. Okay. Whereas if it was heterogeneous, you would have little clumps of the big ones sort of close together and clumps of the smaller ones. Yes. Yeah. Yes. Maybe you finish early, you can work on page 98 if you want to. If you're finished early and you want to take a look at some elemental samples around the room under the microscope, I've got them out for my grade 9. You're quite welcome to. Just make sure when you turn on the microscope, you turn it to I, not to I, not to T or TI. I don't know. When I write microscope,
Get back to the highway. You don't know how. You have no idea what's happening.
So we are going to now go back to some math, okay? A little bit back to math. And so we are going to go to page 81. Page 81. Page 81. Okay, do we know, without looking, here I'll move this over so we can't see it. What is the definition of mass? Tell your partner, what does it mean to have mass? Try not to read it in your book. What is mass? Mass. And if you've answered that one, you can also do the same for volume. What is volume? So mass is the amount of matter in an object. And just because we're here and we can do this, that differs from weight. What is weight? Yeah, it's the force of gravity on an object. So, and the only reason I bring that up now is because even though in like normal everyday life we use the term mass and weight almost interchangeably, in science they are not really interchangeable, because if I want to lose weight, right, I could just go to the moon. Yes? Because I would weigh 1/6 of what I weigh. But if I want to lose mass, I'm going to have to exercise more and eat fewer calories. Yes? So mass is the amount of matter. So if I want less matter in my body, I would have to, do something about that. If I want to lose weight, I can just go where the field of gravity is weaker. Okay? But we're not really focused on that. I just wanted to make that distinction so that you use the terms mass and weight correctly. Okay? Volume, what is volume? Yeah, it's the amount of space an object occupies. Okay? So we have mass, the amount of matter in an object. Volume is the amount of space an object occupies. Tell your partner, what is density? I like that. So part of it becomes compartmentalizing it until you have the math to better understand it. Or if you're like me, you just compartmentalize and be like, I'm never going to understand the math, and I'm just going to make up analogies that work for me. All right, my friends. What is density? The amount of mass in a given volume. Yes, the amount of mass in a given volume. Okay, so we can write that, instead of writing that as a sentence, we can write that as a formula. Density equals mass over volume. Or we can abbreviate that as D equals M over V. So this is one time when you get to choose. You get to choose, do I like solving algebra, or do I like using unit conversions? Because you can solve density problems either way. Yes? So you can say, I like using algebra, so I'm going to use algebra to solve this. Or you can say, I like using unit conversions, so I'm going to use unit conversions to solve this. The only time you can't use unit conversions is when you're actually calculating the density. When you're finding density, you must use the density formula. There's no way to convert mass and volume into density other than doing that division. Okay? So let's take a look at that first example. What was this on page 81? 81. There we go. So for example, and this is all written down for in your book, but I'm going to write it down as we go. We have an iron bar, and it has a mass of 19,600 grams and a volume of 2.50 liters. What is the iron's density? So in order to get full credit for this, for full credit, what might you write first? You would probably write your formula, okay? D equals M over V. So for full credit, number one, you need to write your formula. What might you do next? Plug in values. Have I missed anything yet? Units. Okay, so I would need to put my grams there. I would need to put my liters there. And then finally, I would do the division. Oh, look, it's here for me. I would write, let's see, do I actually get that number or do I get something else? 19,600 divided by 2.5 equals 7,840. And now I need to ask myself, how many sig figs? Yeah, because we have 3 sig figs here and 3 sig figs here. And so my answer should have 3 sig figs. Does my answer have 3 sig figs written that way? Yes, it does. What if I put a decimal at the end? No. What if I put a overbar over this one? No. Okay, so those would be wrong. Those would have 4 sig figs. This is fine. Or you could write it as 7.84 times 10 to the 3. Either way is fine. And what have I forgotten? Units. Okay, so that's going to be grams per liter. And it's going to be 7.84 times 10 to the 3 grams per liter. And what would I like for you to do at the very end? I would like you to box your final answer, please. Okie dokie? Straightforward enough? So if you're asked to calculate density, there is no other way than to use the density formula, plug in the mass, plug in the volume, solve for it. But what if I don't want to find density? What if we have like our next example and we are finding the volume? If mercury has a density of 13,600 grams per liter, what volume in milliliters is occupied by 425 grams of mercury? Now, I personally am a unit conversion girl. I will go unit conversion until I can't anymore, okay? So we're going to start by solving this using unit conversion. What is our unknown quantity here? What's our question word? What volume in milliliters? So we want to know how many milliliters. What is our initial quantity? The initial quantity is always what's attached. So sorry, yes? Yeah, 425 grams. So it's the one that's like attached to the unknown, right? So we've got our initial quantity here. So that's going to be 425 grams. And then our conversion factor, what would we use as a conversion factor? Do we have any in the question? Yes, we do. 13,600, and don't forget to write it one above the other. And of course, if we need to, what can we do with it? Flip it upside down. So we wish to find the milliliters, and we're starting with 425 grams. What do we want on the bottom? Grams. And what can we put on the top? Liters. Now we're not actually at milliliters yet, but we should be able to do a liter to milliliter conversion, yes? So I know that there's 13,600 grams per 1 liter. And then you guys have been doing metric conversions, yes? What would you like to write here? We need to cancel liters and find milliliters. How do you like to write that conversion? Sorry? Yeah, you can use this one because milliliters is one of the ones that we just often know. 1 liter is equal to 1,000 milliliters. If you prefer using the powers of 10 that we've memorized, you could say instead of 1,000 milliliters per liter, you would have milliliters on the top, liters on the bottom. Milli is up here, so your power of 10. 10 to the milli is -3, would have to go on the bottom. You'll get the same answer no matter what, okay? We do the math on that and we get 31.3 milliliters. Now, let's say you didn't want to solve it using unit conversion. Let's say you really like algebra. Totally fine. So method B, density is equal to the mass over the volume, and our unknown is milliliters. So that's going to be our volume, yes? So what would we do with this formula? We would solve for V. And do you remember we solved for V before? If you remember how to do that, that's great. If not, you can use unit conversion, okay? But remember, we're going to take our V, and because it's on the bottom on one side, we're going to move it up to the top on the other side. So now we have V times D equals M. And now we want distance by itself, not distance. It's not even distance. I want volume by itself. So we're going to have to get rid of the density, and so that's going to have to move to the other side. It is on the top, so we will move it to the bottom on the other side. So we will end up with then V is equal to M over D. Okay, and at this point, you can plug in your numbers. The mass was 425 grams. The density is 13,600 grams per liter. All right, and we do that and we get 425 divided by 13,600 equals, I end up with 0.03125, okay? Now, what is my unit there? It's going to be liters. And you can just kind of do that on faith. You can be like, oh, it's volume, it must be liters, and it says liters there, okay? If you really want to understand what's going on, you can say, okay, I have grams over grams per liter. Dividing by a fraction is the same as multiplying by its reciprocal. Okay, so if I have 2 divided by 1/4, that is the same as 2 times 4/1. Yes? So if I have grams over grams per liter, that's going to be the same as grams times liters per gram. Ooh, look at that, it's liters. How nice. Or you can just go on faith. Oh, it says volume, I need liters, there we are, okay? And from there, you could do your final conversion into milliliters. Okay, you would have to use a conversion factor for that. Now, what if we wanted to find there it is. We have 5 minutes, I can do one more example, right? Yeah, the density of silver is 10.5 grams per centimeter cube. This is on page 83 if you want to follow along there, or you can just watch. We want to find the mass of silver that occupies 965 centimeters cubed. Does this look at all like the question you did on your quiz? I've given you centimeters cubed. You need to find the mass. This one's pretty easy, right, to do by unit conversion. You can say, I want to find the mass, I want to find the grams, and I'm starting with 965 centimeters cubed. If I cancel my centimeters cubed and I find my grams, then I get my answer, which is 1.01 times 10 to the 4 grams. So unit conversion, excellent. However, also excellent, we can say I want to use my density formula. Density is equal to mass over volume. I am solving for mass. So in this case, the volume goes up and we end up with M is equal to V times D. There's our volume. Centimeters cubed is a measure of volume, so we have 965 centimeters cubed. And then our density, oh my gosh, this looks exactly like what we had right above. We have 10.5 grams per centimeter cubed. Holy mackerel. Imagine that. Doesn't matter which way you solve it, it actually ends up being the same calculation. Okay? So it's up to you which method you prefer. I would like you to do page 84 for homework. Okay? What else would I like you to be doing for homework? The metric conversions, right? Why do I want you doing metric conversions? Because you have a quiz on Monday. I would like you to come tomorrow with any questions that you have. Where would you find all the extra practice? On our Teams, where it says, hopefully you've seen it already. Come on, Teams, load her on up. Oh my God, you're killing me. The circle goes around. Oh, the lag. Ugh. If you go to upcoming quizzes and tests, if you can get past the turning circles. Oh, look, it says extra practice. In the pink workbook, pages 70 to 71, 76, 77 to 79, plus 80 if you want enriched practice on squared and cubed. And there's also some stuff in Hebden. Where would you find that? In the upcoming quizzes and tests. Would you like me to also put it in the homework? Yes? Okay, I will do that. Hi. Hi. Yes.
Sign my hand.
Okay. What would you like me to sign in?
Any pen.
Okay. You probably don't want a Sharpie.
Probably not.
I don't have like belts.
It's okay.
But that'll hurt.
No, it's okay. Evan already engraved his whole name in me, as you can tell. So it's like, it's okay.
Okay. I've got an erasable pen. How's that?
If that works, then that's fine.
Okay.
Where would you like to put it? Oh. Let's hope that stays.
It's the best I can do on there.
I appreciate it. Thank you.
The electric spinning, the electron spinning is weird.
Yeah, right?
They must have opposite magnetic fields to each other. Why?
Because that's the way it works. I guess it's kind of like if you have a North Pole, it needs to be near a South Pole.
Okay.
That's how I rationalize it in my head.
And then the nuclear spin. How does that not?
I don't know I don't even know that the nucleus spins. I have no idea.
Like
Does the nucleus spin?
Yeah.
Where does it say? Nuclear spin.
Not
Oh! Well, that's fantastic. I never read that.
And this is. I went back a bit and tried to do some pre-reading.
Yeah.
And so this is the numbers that represent the shells, in a sense, not the shells, but these. And then this is the three-dimensional graph that shows you the probability in each sector, basically.
Yes.
Is that what kind of it is?
Yes.
And that's the probability of the electrons that are where they are, although you can't see them, they are spinning.